This video is on uncertainties. So let's learn how to add, subtract, multiply, and divide uncertainties. So question 1, we want to add 3.14 plus or minus 0.15. 0.15 is the uncertainty. So the value that we measure could be 3.14 plus 0.15 greater or minus 1.5. Sorry, 3.14 plus 0.15 greater or minus 0.15 less. And we're going to add it to 9.26 plus or minus 0.53. So that measurement of 9.26, it could actually be 0.53 greater or 0.53 less. So this equation highlighted in blue is what we're going to use to add and subtract uncertainties. So if y equals a plus or minus b, then delta y equals delta a plus delta b. So it doesn't matter if we're adding or subtracting uncertainties, we're going to use this equation. So first we add the values. 3.14 plus 9.26 gives us 12.4. Then we add the uncertainty, 0.15 plus 0.53, which gives us 0.68. So our solution, remember, the uncertainty should only be one significant figure, and our value should be at the same decimal or the same point as our uncertainty. So since our uncertainty is at the 10th place, 0.7, our value should be at the 10th place, 12.4. So memorize these two in yellow. The uncertainty should have one significant figure, and the least significant figure of the solution must be in the same place as the uncertainty. So now you could do question 2 on your own since you're adding uncertainties. And see that the uncertainty 0.67 is going to be rounded to 0.7. Question 3, once again, you're adding uncertainties. And you could see that the uncertainty is 0.013, but it needs to be rounded to one significant figure. So the value is going to be 0.01. And the value is also going to end at the 100th place. So the value is going to be 20.06. Question 4, we are subtracting uncertainties, but notice we're using the same equation. So we're going to subtract 5.89 minus 3.23, and then we're going to add the uncertainties. So our solution is going to be 3 plus or minus 2. You could see it says here you cannot have 0 or negative uncertainty. So subtracting uncertainties does not make sense. And notice when subtracting numbers, the uncertainty becomes large. So our value is 3 plus or minus 2. I mean, that's huge, right? Our values could be between 1 and 5. Question 5, we're subtracting uncertainties. You could do this yourself. It's very similar to question 4. Question 6, we're subtracting uncertainties again. Sorry, we're subtracting two values, but we're adding the uncertainties as usual because we're using this equation in blue. Question 7, this is where things get tough. We are multiplying uncertainties, okay? So look at the equation in yellow. If y equals ab over c, then delta y over y equals delta a over a plus delta b over b plus delta c over c. So look at what we have and look at our equation in blue. So we could see that since we're multiplying numbers, C in that blue box, highlighted in blue, is going to be equal to 1. So delta C is going to be equal to 0. So now our equation simplifies to delta y over y equals delta a over a plus delta b over b. Y is going to be 3.14 times 9.26. And now we could solve for delta y by plugging in all of those values into the blue equation. So really understand what's happening. First we multiply to get y, and then we plug into the equation to get delta y. Question 8, same thing. When we're multiplying or dividing, we're going to use this equation. And since we're multiplying, C is going to equal 1. So delta C is 0. So the first thing we have to do is solve for y. Second step, we're going to plug in everything into the equation and solve for delta y. Question 9, we're multiplying uncertainties again. So C is going to be equal to 1, delta C is 0. Step 1, solve for y. Step 2, plug in to everything in the blue equation to solve for delta y. Question 10, we're dividing uncertainties. Remember, adding and subtracting uncertainties uses the same equation. Multiplying and dividing uncertainties uses the same equation. So in this case, since we're dividing uncertainties, b equals 1 and delta b is 0 from that equation in blue. We plug in everything. The first step is to find y, which is 5.89 divided by 3.23. And then the second step is to plug in everything to the equation and solve for delta y. If you could understand and do problem 10, you could understand and do problem 11. So just recognize we are dividing. So b is going to be equal to 1, delta b is 0. That equation in blue gets simplified. Step 1, solve for y. Step 2, solve for delta y. Question 12, we are dividing uncertainties. So if you could do problems 10 and 11, then you could do problem 12. We've just added and subtracted uncertainties and multiplied and divided uncertainties. Now we're going to take an exponent and to determine the uncertainty. So we have to determine 3.14 plus or minus 0.15 to the second power. So understand this equation highlighted in blue. If y equals a to the nth, then delta y over y equals n times delta a over a. So the first step is to find y. So we're going to determine 3.14 squared. Then the second step is to plug in everything to the equation to find delta y. So remember, the uncertainty should be one significant figure. So question 14 is very similar to question 12. We're using this equation. Try to understand what's been done here. The uncertainty should be one significant figure. Question 15. We're taking the exponent of an uncertainty. We're using this equation again. Question 16, this is an exponent because the square root is just to the 1/2 power. Question 17, this exponent is to the 1/3 power. In question 18, this exponent is just to the 1/4 power. Here are some word problems. What is the percent uncertainty of the perimeter of a rectangle if it has the length of 2.45 plus or minus 0.3 meters and a width of 3.56 plus or minus 0.4 meters? So, step 1, determine the equation for the perimeter of a rectangle. Step 2, use the equation. Step 3, determine the fractional uncertainty. Step 4, determine the percent uncertainty. So you got to get really comfortable at this. Just take it one step at a time. You cannot go to step 4 by itself. You have to do steps 1, 2, and 3 also. Question 20. What is the percent uncertainty of the area of a rectangle if its length is uncertain by 3% and its width is uncertain by 4%? So look at the equation here. Area is equal to length times width. And when we're multiplying the percent uncertainty, we're just adding them up. So the answer is 7%. Question 21, what is the percent uncertainty of the volume of a box if its length is uncertain by 3%, its width is uncertain by 4%, and its height uncertain by 5%? This is what we get here. By using the equation, we just add up the uncertainties. Question 22, what is the percent uncertainty of the perimeter or circumference of the circle if its radius is uncertain by 7%? So take a look at that equation. Circumference is 2 pi r. Well, 2 pi is not a variable. 2 pi stays the same forever. So there's no uncertainty in 2 pi. The uncertainty in 2 pi is 0. So the percent uncertainty in the perimeter or circumference is 7%, just like its radius. Question 23, what is the percent uncertainty of the area of a circle if its radius is uncertain by 7%? We're going to use this equation. A equals pi r squared. This is an exponent, so we're going to use this equation in blue, highlighted in blue. So our percent uncertainty is 2 times 7%. Question 24, what is the percent uncertainty of the volume of a sphere if its radius is uncertain by 7%? Well, let's first find the volume of a sphere. It's 4/3 pi r cubed. We know 4/3 pi has no uncertainty. So our solution is going to be 3 times 7%. Question 25. Mustafa has a height of 172 plus or minus 0.2 centimeters. Noor has a height of 167 plus or minus 0.35 centimeters. How much taller, including uncertainty, is Mustafa taller than Noor? This is what you do. So just understand how to translate a word problem into an equation. Question 26. 12 identical square tiles each have a length of 45.62 centimeters with an uncertainty of 0.2 centimeters. What is the total length, including uncertainty, of the 12 tiles if they are placed side by side? So our equation is given L equals 12 times 45.62 plus or minus 0.2 centimeters. We notice that we are multiplying. So 12 has an uncertainty of 0. C has an uncertainty of 0. So essentially we're just doing 12 times 45.62 to solve for y. And then we solve for delta y. Question 27. What is the perimeter including uncertainty of a rectangle with a length of 3.14 plus or minus 0.15 centimeters and a width of 9.26 plus or minus 0.53 centimeters? First, we determine the equation. Second, we solve. Third, we're going to use this equation 2 times length plus width. And then finally, we're going to get delta y, which is 1.36 centimeters. Question 28. What is the area including uncertainty of a rectangle with a length of 3.14 plus or minus 0.15 meters and a width of 9.26 plus or minus 0.53 centimeters? So they want the area of a rectangle, so we need to find the area of a rectangle as length times width. So this equation in blue, we know delta C is 0. So first we solved for y, and then we solved for delta y. Question 29. What is a volume including uncertainty of a box with a length of 3.14 plus or minus 0.15 centimeters, a width of 9.26 plus or minus 0.53 centimeters, and a height of 6.26 times 0.43 centimeters? So step 1, we need the equation. Area equals length times width times height. Step 2, let's solve for this equation. So we've determined y, which is 3.14 times 9.26 times 6.26. And then we solve for delta y. Question 30. What is the perimeter or circumference including uncertainty of a circle with a radius of 3.83 plus or minus 0.27 centimeters? So we need the equation of a circle, the equation of the perimeter of a circle, also called circumference. It's 2 pi r. Let's use this equation. Delta B is 0 and delta C is 0. So our solution is 24 plus or minus 2 centimeters. So y is going to be 2 pi r, 24.0646, and then we could solve for delta y. Question 31. What's the area including uncertainty of a circle with radius 3.83 plus or minus 0.27 centimeters? Equation for the area of a circle is pi r squared. Since it has an exponent, let's use this equation highlighted in blue. And then let's solve for y, which is pi r squared, which is pi times 3.83 squared. Then let's solve for delta y. Question 32. The volume of a right cone is given by the equation v equals 1/3 pi r squared h. Determine the uncertainty in the radius of a right cone if the uncertainty in its volume is 6% and the uncertainty in its height is 8%. So first solve for the radius. And then we could just plug it into this equation to get 7%. Remember, 3 and pi have no uncertainty. Those are values. Those are not variables. Question 33. The surface area of a sphere is given by the equation v equals 4/3 pi r cubed. Determine the uncertainty in the radius of a sphere if the uncertainty in its volume is 6%. So first step, solve for the radius. Second step, just use the equation in blue that I've given you previously about exponents. Which is this equation here. So this equation here is going to be used for equation 33, and 32. Question 34. What is a volume including uncertainty of a sphere with radius of 3.83 plus or minus 0.27 centimeters? So step 1, determine the equation for the volume of a sphere. Write it down. Step 2, calculate y, which is 4/3 times pi times 3.83 cubed. And then plug all the values into the equation in blue to solve for delta y. Question 35. What is the speed, including uncertainty, of a boat which travels 31.41 plus or minus 0.59 meters in 2.65 plus or minus 0.35 seconds? So, step 1, determine the equation for the speed of the boat. Speed is distance over time. Looks like we're dividing. So now we have to use the equation in blue. So b is 1, delta b is 0. We could solve for speed, which is 31.41 divided by 0.59. Sorry. The answer is going to be meters over second. So it's going to be 31.41 divided by 2.65. That's meters over second. And that's 11.8528. So that's y. Then we plug in everything to the equation to get delta y. Question 36. A circle has a radius r and a square has a side length 2r. Calculate the following. Percent uncertainty of the area of the circle divided by percent uncertainty of the area of the square. So the area of a circle is proportional to r squared, and the area of a square is proportional to r squared. So if you look at these two equations, pi r squared and 4r squared, you're going to notice that n is equal to 2 and n is equal to 2. So if you divide the two, the percent uncertainty of the two, if you divide the two, is going to be equal to 1. Finally, 37, the length of two large bedrooms are measured to be 25 plus or minus 1 meter and 20 plus or minus 1 meter. Order the 4 fundamental functions in order of the least percent uncertainty to the most percent uncertainty. So we actually have to do a plus b, a minus b, a times b, a divided by b. And you notice a plus b, our percent uncertainty is 4.44%. When subtracting, percent uncertainty is 40%. When multiplying, percent uncertainty is 9%, and dividing, percent uncertainty once again is 9%. So the problem tells us to order from least percent uncertainty to most. So the least uncertainty is adding, then multiplying and dividing is equal, and then finally subtracting gives us the most uncertainty.